Our next topic, we're going to look at starting to factor trinomials. So remember, trinomials, you've had that prefix tri. So that means you are looking at terms with three, or expressions with three terms in them, rather than just two. Before we do this, though, one of the things that we can do to check our work is actually thinking about what happens when we multiply expressions back together again. So before we do our examples for today, I wanted to go through a couple of those as well. So you may find these on the back page or second page of the organizer that I posted. Okay, so you might have heard of this as foiling, but technically all we're doing is a very organized method of distributing all of our polynomials to make sure that we have all of our parts multiplied. So if we look at something like example 1, and this looks a lot like those solutions we got out when we were multiplying, or excuse me, when we were factoring out our groups using our GCF. So how can we tell whether or not our solutions are correct? So we want to take a very, very specific order to this just to help keep track of what things we're doing. So we have to multiply all of 4x plus 3 times all of 2x minus 7, which means each one of the terms inside each group has to get multiplied by each term inside the other group. So let's start with this 4x. So I need to multiply him by both the 2x and the negative 7. So I'm just distributing him. So I'm going to do, and I'm going to write out multiple steps on here. So I would do 4x times 2x, and then I'm going to do 4x times a negative 7. Okay, then I'm going to do the same thing with the 3. So positive 3 has to get distributed over both terms. So that's going to be a 3 times negative 7. Excuse me, let's do this in the same order that I wrote it in. So negative 3 times 2x plus 3 times negative 2. And again, you'll notice I'm adding my terms, but I still want to keep track of all my negative signs. So then let's just combine our like terms and see what we're looking at. So 4x times 2x actually gives me 8x squared. 4x times negative 7 is going to give me a negative 28x. 3 times 2x is going to give me a positive 6x. And 3 times negative 2 is going to give me a negative 6. But we have those two terms in the middle that we can combine. And so let's go ahead and combine negative 28x plus 6x. And again, we're just combining our coefficients because our variables are exactly the same. So that comes out to be 8x squared minus 22x minus 6. And so think about the order of which I organize things in. And this is going to come into play when I start checking my solutions from factoring. I'm going to be looking very specifically at how I ended up with that middle term of negative 22x. So if I think about 3 times 2x, that gave me my 6x. And I think about 4x times negative 7, which gave me the negative 28x. Those ultimately ended up making that negative 22x when I combined my like terms. Okay, let's look at our next example. So this one's a little different. It has a 3x sitting out front, which we're going to start seeing in some of our factoring. But before I apply that, I want to work just with the two sets of parentheses. Now you think, well, why can't I just multiply that 3x over everything? Well, keep in mind, you're trying to do this very systematically. And if that 3x is sitting out front, then that means it's going to be multiplying the result of the two sets of parentheses when they get multiplied out. If I multiplied the 3x over everything in both sets of parentheses at this stage, I'd actually be multiplying it into two separate groups. So I'm really multiplying it twice through instead of just once. So with these values, always hold off to the end with these. So this is really going to be 3x times whatever I get out when I multiply these two sets of parentheses. So again, I want to do this systematically. So 2x squared times 3x, well, that's going to give me 6x cubed, right? Because x squared times x gives us x cubed. 2x squared times positive 2 will give me positive 4x squared. Then I want to do the same thing with the negative 1. Negative 1 times 3x will give me a negative 3x. And then negative 1 times positive 2 gives me a -2. Now with this, just because of the nature of the terms that we had, we don't actually have any other values that we need to multiply or combine like terms with, because we don't have any matching x's. Every single term has a different number of x's being multiplied in. So now I can take that 3x from out front and distribute him over the results that I found. So this is going to make 18x to the 4 plus 12x cubed minus 9x squared minus 6x. And so these are our final answers when we multiply those out. Okay, so let's apply some of the ideas that we used last time and what we talked about this time with factoring trinomials. So again, anytime you're trying to factor, you're trying to basically get back to the scenario like we had with these two examples where we have our factors kind of grouped out in the most simpler terms. When we see them all multiplied out with the 3 or 4 terms, you know, it's hard to see how things are interacting with each other. And we're actually going to use this a lot. We're going to do some application problems later this unit, and you're going to see how this is extremely important in our next couple units with quadratics and polynomials when we start looking at those functions. So let's go back up to the beginning of the first page. So when we factor trinomials, we want to make sure that we're finding terms m, n, p, and q, bear with me, so that when we put them in the order that I have at the top of that paper, mx plus p all times nx plus q, where when we combine those, we'll get back to that original trinomial. Now this looks a little wacky in algebra when I kind of write it out in more general terms. So let's look at this in terms of some actual number examples. So again, we have our steps on the right-hand side. Let's follow through. So in general, with this, we want to look at what happens when we multiply our a times our c. In other words, the coefficient of our first term and the coefficient of our last term. Now, the way I'm going to show you this will work in any trinomial factoring, but with future problems, I'm going to show you kind of a shortcut. A lot of times we call it kind of guess and check. That'll get us into factoring a whole lot quicker. So let's do this. Our leading coefficient on our x squared is just a 1. So if I think 1 times 10, I'm thinking about 10. Okay, so that's what happens when I multiply a times c. So now I need to brainstorm factors of that result, then find what's going to happen with their sum. And you're going to see why I'm doing this in a second. So I'm brainstorming factors of 10. And the only way that I can break down a 10 is either 1 times 10 or 2 times 5. Now, if I think my factors, that's different than sums. Sums is when I'm going to add. So 1 plus 10, well, that's going to give me an 11. 2 plus 5, that's going to give me a 7. So why do you think I'm doing this? I'm looking for that middle term. Our original problem has a 7x as the middle term. And so what I'm actually going to do is I'm going to break down that 7x and rewrite this whole expression as x squared plus 2x plus 5x plus 10. So really all I did was I expanded that middle term into 2 values, and this is why I did this. Last class, last lesson, we looked at factor by grouping. So let's apply that. So our first 2 terms both have an x as a common factor. And when I factor that out, I'm left with x plus 2. My second grouping, 5x plus 10, well, both of those, they have a common factor of 5. So when I factor that out, I'm left with that x plus 2 again. And if we apply our factor by grouping, then our final solution would come out to be x plus 2 was our kind of common group, and our leftovers were x plus 5. And we are now fully factored out. So that's where this methodology comes from. But you're not going to want to go through and do factor by grouping on every single problem. If you have a quicker way to get into the problem, then we should probably use that. And especially if you're going on to future math classes where you're going to have to do a lot of factoring and it's just going to keep coming up in different topics, you're not going to want to have to stop every single time to write out all these extra steps. So check out where our numbers kind of came out of. So we had our 10 that we were looking at for our overall item. And that's because when we look at our original problem, that 10 is what we need to get when we multiply those last two terms together, kind of the P and the Q in our definition. So that always has to multiply to make that last term. But then we also have to check how are we going to get that middle term. So the middle term, let me change colors. Let's go back, let's go to green. Okay, so the other terms that we're looking at, we have to get to that 7 in the middle. So if I check my middle two terms, which again, was I multiplying these back together again to check, I'd end up multiplying those two together. And we have a x times 5 or 5x from the outside terms. If I put those 2x and the 5x together, it makes that 7x that we were trying to make. So when I'm going through with the shortcut method, I'm still going to check those two multipliers that I just highlighted in the green, but I might not write those middle two steps that I put in the red and the blue. So let me show you what I'm talking about. Okay. Example 2, we're going to factor m squared plus 2n minus 24. Okay, so let's think about that 24. We're going to have to find something that when we plug into our format, these two values are going to multiply to make a negative 24. So let's brainstorm some factors over on the side here. Okay, so we could do 2 times 12. But we'd have to come up with a couple different combinations. If we're multiplying to get a negative 24, that means we'd have to either multiply by negative 2 times 12 or 2 times negative 12. But then let's think about that same thing we were doing with brainstorming before. When we add them, they're going to have to come to that 2n in the middle. And that is not going to happen with any combination of negative 2 and 12 or 2 and negative 12. So I need to keep going on my brainstorming. So what are some other things that we could multiply to make a negative 24? Well, what about 3 and 8? And again, if we think about our combinations, like negative 3 times positive 8 or 3 times a negative 8. But again, when we try to add those together to find the sum, it's not going to get us to that 2n that we're looking for in the middle. So those won't work. So another combination we could use would be 4 and 6. So again, either negative 4 times positive 6 or 4 times negative 6. So which one of those could I add to make a 2 for that middle term? Well, if I have a positive 6 and a negative 4, that's going to work. So actually, once I have those picked out, as long as my leading coefficient is 1, which we've got on all our problems for today for the factoring, then all I need to do is fill it in. So this is actually going to factor out to m, then I'm going to use my minus 4, and m, I'm going to use my positive 6. If you don't believe me, you can multiply it all the way out, but the pieces that are going to be the most helpful to check are kind of the inner products and your outer products. I already know that negative 4 times 6 gives me that negative 24 that I was looking for. That's where I got those numbers in the first place. But if I check my other kind of multipliers, if I check my other values, I have a negative 4 times n and a 6 times m. And again, when I combine those, positive 6m minus 4m makes that negative, or that positive 2 that I was trying to match in there. So my final factoring, my final solution is m minus 4 times m plus 6. Let's try another one. Okay, this one looks a little different though. I don't have a leading coefficient of 1 on this, but do you notice anything in common with all these terms? They all have a 2. So for this one, I'm actually going to take an extra step and do what we did last class and factor out a GCF. So every single one of my terms has a common 2. So really, the expression that I want to look at is a squared plus 11a plus 13. So really what we're going to concentrate on factoring is that a squared plus 11a plus, excuse me, not 13, 18. Alrighty, so we need to work on brainstorming what's going to get us that positive 18. So because it's a positive 18, and I've got another positive value in here, I'm not going to mess around with positives and negatives on this one. We're just going to look at positive values that could multiply up to 18 that could then also sum to that negative 11 in the middle. And so brainstorming my factors, and I have 1 times 18, and add those up, I get 19, it's not going to work. I have 2 times 9. Well, wait a second. 2 times 9 gives me an 18. 2 plus 9 gives us the positive 11. So that's actually my factoring. So I have an A plus 2 and an A plus 9. And I copy down the 2 that my GCF was that I took out in that first step. And again, always double check. If you're not quite sure, you can multiply it out completely like we did at the beginning of the lesson. But if you check just your inner and outer multiplications, there's our 2A and our 9A, which will give us our positive 11A from our factoring that we were looking for. So that is our final solution. 2 times quantity 8 plus 2 times quantity 8 plus 9. Okay, let's try a couple more. So these, you'll notice I don't have any leading terms, so we don't have to worry about factoring out that GCF in our first step. We're just going to focus on, let's brainstorm on that 24. But this one has a negative sign in the middle, so that means I know I'm going to have to subtract something when I'm looking at, whether my factors add to that middle term. So what's the only way to take factors that multiply to make a positive, but I can add or subtract to make a negative? Negative times negative. So I'm looking at 24. I'm going to look at all negative factors. So I could do negative 1 times 24 times negative 24. That's not going to give me a negative 4. Negative 2 times negative 12. And negative 14, I'm getting closer, but not there yet. Negative 3 times negative 4. And add those up, I get a negative 7. I'm even closer, but I'm not there. What else could we use? Excuse me, I'm looking at 24, so it's not negative 3 times negative 4. It would be negative 3 times negative 8. That still doesn't work, though. That gives me a negative 11 when I add them. So how about negative 4 times negative 6? Wait a second. Do we have any other factors that we could use? So that means I can't find a combination of values that will multiply to get us a 24, but add to get us the negative 4. So sometimes this is going to happen. If you have no factors that work and you are absolutely sure you have all of your pairs of factors, it could be possible that you have a non-factorable expression. And in fact, this one is non-factorable. And again, even if we tried to go back to using factor by grouping, we're going to find we have some problems because, again, we can't find a pair of values that's actually going to work to give us that negative 4 unless we start messing around with our positive and negative signs, in which case we're not going to have the positive 24 when we multiply anymore. Okay, example 5. So I'm focusing on that negative 56. That's what we want to brainstorm on. We're trying to make negative n, what's our implied coefficient? We're trying to make a negative 1. So that means we're going to multiply. To get a negative, we need to do a positive and a negative, and then when we add those together, we'll end up with a negative 1. And so what are some factors of 56 that you can think of? Well, we could do 2 times 28. And if we're going to kind of add or subtract, that means we need to be just 1 away from each other in factors. We're way too far away with the 2 and the 28. We could do 4 and 14, but again, they're too far away from each other. We'd have a difference of 10, whichever way we order our negative sign. Okay, well, what about 7 and 8? Those guys are only 1 away, so we just need to make sure we have our signs correct. So we could either multiply negative 7 times positive 8, or positive 7 times negative 8. Which one of those, when we add them, gets us a negative 1? Well, that's going to be when we have the negative 8. And so those are our 2 factors, technically our 2 values that we're going to write in at the end of our parentheses. So we're looking at n minus 7 and n plus 7 and n minus 8. Okay, go ahead and pause the video and try the you-try examples. Okay, so let's see how those went. Okay, for this one, we are brainstorming on a 50, trying to get a negative 15. So let's see. The first one that I'm thinking of, especially when I have these values that end in a 0, I tend to look at, well, what happens when I divide out by 10? So this is really 10 times 5. But if I'm trying to get that positive 50, I could also use negative 10 times negative 5. Still gives me a positive 50, but when I add those together, I'm going to get that negative 15 that I'm looking for. So my factoring on this one is x minus 10 and x minus 5. And again, keep in mind multiplication is commutative, so you might also see this written as x minus 5 times x minus 10. You still have exactly the same factors, exactly the same signs on your values, so it doesn't matter if you flip-flopped your sets of parentheses. Alrighty, so then our last example, 3b squared minus 18b plus 24. Again, I've got that leading 3, and looking at all three terms, they have a common 3. So let's factor that out first, which will leave us with a b squared minus 6b plus 8. So really, we're brainstorming on that positive 8. But because we're trying to get a negative 6 in the middle, we want to look at combinations of positive and negatives. Again, how can I multiply to make a positive but still involve negative numbers? Negative times negative. And because our value is kind of small, we don't have too many to check. We could do negative 1 times negative 8. And we could do negative 2 times negative 4. Well, when I add negative 2 plus negative 4, that gives me my negative 6. So my factoring is b minus 2 and b minus 4. And again, I could do the order, I could do this in any order as long as I'm keeping the b minus 2 and b minus 4 together inside a group. As always, let me know if you have any difficulties, any questions. Our next lesson, we're going to look at more of those problems where we have something in the very first term that doesn't start with a 1. So we'll look at those next class.